So you can see that it's directly proportional to the square of the initial velocity. The faster the object is moving, when you notice it or when it begins to apply the brakes, the more is the distance needed. So we have to control this so that the distance value drops. If let's say this is 20 meter per second, then this S value will increase. If this is 10 meter per second, this will be lesser accordingly. So we can set the speed limit accordingly. And you also see a negative sign here, which indicates that the car has to decelerate. It's not the moment the driver decides to stop and he hits the brakes. Of course, the deceleration of the car depends upon how strong the brake is, how quickly the driver reacts, and the make of the car, and so on and so forth. Right? But then we can accordingly approximate that and then find out the speed to be set. Obviously, it cannot be 50-60 kilometers per hour. It needs to stop at some distance. Let's assume that and let's take a case where the car's acceleration once he hits the brake is 5 meter per second square. This is the rate at which it's decelerating, or rather minus 5 meter per second square according to convention. So then if V has to be 0 equals let's say the velocity at which it's traveling, U, is 10 meter per second. It's traveling at 10 meter per second and the driver slams the brakes. It starts accelerating at minus 5 meter per second square or decelerating at 5 meter per second square. Let's find out from this formula what the S will be. It needs to reach a velocity of 0. So the braking distance has to be 100 divided by 2 times A, which is nothing but 10. So 10 meters. So if a car is moving at 10 meters per second velocity, then roughly approximately all cars stop at of average make and driver response decelerate at 5 meter per second square, then it will stop at a distance of 10 meters. So maybe we can set the speed limit accordingly at 8 meter per second and convert it to kilometers per hour and set it. So this is what braking distance is and its significance. Thank you.